So we've discussed that in physics we have this standard system of units, meters, kilograms, and seconds, that are the preferred units. But in everyday life, people express quantities in all sorts of different kinds of units because these units are more familiar or more intuitive to them. So we need to be able to convert from one type of unit to another. So let's do a few practice examples of unit conversions. And keep in mind that for my class, I don't expect you to memorize any of these unit conversions. If you're doing homework or lab or something, just get on Google or your textbook and look up the conversion factors. On a quiz or an exam, I'll provide you with any conversions that you might need. So first example, let's turn 15 inches to centimeters. And the process that I use is to start out with that given quantity and multiply by a conversion factor, where you have some relationship between the desired quantity and the original quantity, keeping in mind that units obey the rules of algebra. So if I have inches in my numerator, then I put inches in the denominator in the conversion factor so that they cancel, and I'm left with centimeters. Next example. You can have situations where you need to convert more than one type of unit. For instance, a speed. Let's convert 28 meters per second to miles per hour. .28 meters per second is how many miles per hour? Well, I start out with my known quantity, and I multiply by a conversion factor for meters to miles and another conversion factor for seconds to hours. So let's do the meters to miles first. It doesn't matter what order you do it in. 1 mile is 1,609 meters. You don't have to memorize that. And 1 hour is 3,600 seconds. If you wanted to do this in 2 steps, you could. You could do 60 seconds in a minute, 60 minutes in an hour. Gives you the same thing, because 60 times 60 is 3,600. Now keep in mind, I'm making sure to write these conversion factors so that the proper units cancel. If you're uncertain which way they should go, whether I should have put the miles on top or the miles on the bottom, remember that we're trying to cancel out the meters, because we don't want meters in the final answer. We do want miles. So those meters need to go on the bottom so they cancel. Likewise, the seconds over here need to go on the top so they cancel with that seconds. So plug that into your calculator and you get 62.6 miles per hour. Let's do another example. This is converting accelerations. So So an acceleration is a quantity with dimensions of length per time squared. So let's go from meters per second squared to kilometers per minute squared. Same procedure. Oops, 22 meters per second squared. That's my given quantity. Now let's convert those meters to kilometers. We know that 1 kilometer is 1,000 meters. And we know that 1 minute is 60 seconds. But now here's the tricky part of this problem. Whenever you have quantities raised to some power, you must raise the conversion factor to that same power. So this whole thing gets squared, which means that this squared applies to the 60, it applies to the seconds, it applies to the 1, and it applies to the minutes. So just for the sake of being really, really clear this first time that we do it, this whole formula looks like that. I distributed the squared everywhere. And of course, 1 squared is just 1. So now you can see that those seconds squared cancel out over here. These meters cancel out. And we are left with kilometers per minute squared like we wanted. And it is 79.2 kilometers per minute squared. Let's do one last example. This is a density. Let's say we have 4.5 times 10 to the third kilograms per cubic meter. Mass divided by volume. That's density. And we want to convert it to grams per cubic centimeter. .5 times 10 to the third kilograms per cubic meter. We'll do a conversion factor for the kilograms to grams. There are 1,000 grams in 1 kilogram. And we want centimeters cubed on the bottom, so we got 1 meter is 100 centimeters. That whole thing is cubed. So we've got 10 to the third, 10 to the sixth, divided by 10 to the sixth, which is going to be 4.5.